All right. Why am I using a 252? Can someone tell me? Because, correct, it is a /30. Oh, yeah, I forgot the last octet. Okay. And this device is the DCE, which tells me to do what? Very good. So we set the password for telnet connections to telnet. And then we set our console password to console. Finally, what am I doing here, gang? Okay, I'm setting my gateway. I'm on the ISP router, and I'm pointing back to this interface over here. So I'm here, and I'm pointing back over here. Any questions so far? Let's exit back to our privilege mode. Let's do a show running. Nothing's on our fast Ethernet ports. Gang, I really don't feel like talking over people. If you've got a question for me, let me know. You've got serial 030. It's set with an IP address. It has a clock rate. Nothing for the VLAN. We're really not using that VLANs in this problem at all. But you will notice that we have an IP default network of 235.76 and 2. All right. So the configuration on this ISP router is complete. We really don't have to do anything with respect to ACLs, with VPNs, and so on down the line. Or not VPNs, but NATs. All right, so here we are at our corporate router, and we're going to get this thing configured. So first we'll work on the basics. Host name, and we'll simply call it corporate. Then let's configure our interfaces. We'll start with S030. IP address on this. That'll stop in a moment. Now this is the DTE, therefore I must do what to it? With respect to clock rate? Nothing. So then we put in our no shut, and that thing now comes up. You'll notice we've got 2 green lights on that link. We are good to go. Yes, I did. Yes, I did. Or I thought I did. Yeah. I always do it anyhow, just to make sure. All right. Let's see. We've got int, and what's this port here? This port is F00, and this one is F01. Okay, fine. So int F00, and it has an IP address of 172.16.10.1 255, 255, 255, and 0. No shut. And that line now starts coming up. The other end, why isn't the other end coming up? Anyone? Say again? It's the switch is actually coming up and is now trying to figure out what are going to be trunk ports and so on. Wait a minute, am I doing the right lab?
Yes.
Okay. God. Okay, and there goes that one. Okay, now, at this point, let's see, let's back up, go to our configuration, global configuration mode, and again, I'm going to set my default network to 12.235.76.1, and I'm pointing the other way now. I don't recall. Do we have all of our IP addresses set on the host? Do I have to set those? Okay. Let's go in and do that. So to begin with, my gateway should be 1. My fast Ethernet should be, I'm running a little late, babe. Why don't you sit down? By the way, this is Scott's lab, so if I screw up anything, we'll blame it on Scott. Well, I want to make sure you get due credit. All right. All right. Let's just get PC1 up and running for the moment. .10. Okay, we look good. All right, so let's go to our desktop. Let's just try pinging some things. Okay, we're not getting that far. Let's see if we can ping our default router. Looks like we still have an issue. Scott, you didn't do anything in terms of configuration to the switches, did you? Okay. Oh, okay. You got VLANs in here. Good. Okay, we've got 10.10. And we've got 10.1. 10.1. Okay, I've got two interfaces that have 10. No. 72. Okay, I'm good. Oh, thanks. Thanks, Justin. There we go. Okay, I've got success there. No, because of where I'm at. Look at my prompt. If you basically attempt a ping in the global configuration mode, you have to do a do. But if you do it in privilege mode, you just forget to do. Okay. Okay, what's this? Shoot. So I'm cleaning up a couple of things. Okay, good. Anybody have any questions so far? See, I'm in privileged mode right now, Scott, so I just say show. Say again? Correct. Well, no, just shows. Shows and pings and things like that. Okay, there it is. Okay, we've got that. It times out because what's happening is ARP has to run. The MAC table in the switch is not filled, so it's basically learning the MAC address. So it basically fails on the first one, but if you were to look at the second one, it would come back as just fine. And then if you were to ping it again, you'd get 100%. Let's go back the other way, no problem. Okay, let's go the other way and see if we can find that. I haven't even started on the access list yet. I'm just trying to get, the network up and running at this point. Okay, I've got 100% down, so we're good to there. So why aren't we distributing? Let's go to our corporate router. Gang, I'm unable to ping. What would you recommend that I look at next? Say again? I'm not able to ping from PC1 up to the ISP router. I can ping from PC1 to the WW server and back. What would? Okay, let's take a look at the route. Oh, wait a minute. We've got a static gateway of last resort is not set. That's not right because it should be set. Everybody see that? When I put in my default network, I should have gotten a show run. Okay. Why does that thing keep coming back? Okay, now you see the static route is assigned up above here. Okay, that's good. But this thing, and you also see it down below here with the S asterisk that identifies a not only a static but the default. The problem is this piece right here. That's bothering me. And it's right here that's no IP. Okay, I'm going to go with that. Okay, now everything looks okay. Now we should be able to ping. Maybe not. Okay, there's another problem. Gang, do you see these commands, IP default network and then IP route 000? These commands are supposed to be equivalent. Okay, they do exactly the same thing, but I'm seeing that there seems to be an issue with the default network command. So, no, it does not appear to be working, and it comes out looking very strange. It could be packet tracer. Okay, so here it is. This is the way it should look. So we're good there. Let's check the routing table. And now that looks good as well. Notice it says gateway of last resort, and it points back down to our corporate router. And we also have this S asterisk here. Now, come on. Oh, there we go. Okay. Finally wakes up. Okay, so, gang, the first thing that we need to do is we need to set up an ACL that basically controls access to the various servers. If you recall, what we want to do is everyone on both internal and external may access the WW server, but is limited to HTTP. Switch this over. And access only any other port is disallowed. We also want to allow for PC4 to access the finance server on 30 and access PC3 to access the accounting server on 20. Okay? So where are we going to write this access list? Okay, which router? Corporate router, what port? Actually, you want to put it on 172.16.10.1. Okay, FA00. And the reason for that is you've got external traffic potentially coming in and coming down here, and then internal traffic coming up and coming down. So this is the port that we want to put the access list on. So let's first write the access list. Now there are two ways that we can write the access, the old access list or the new access list. The new one starts with IP, the old starts with just access. And It would help if I got in the right mode. And if I could type right. Yeah, thank you. All right, I'm going too fast. All right, so we've got access list, and then we define what type of access list we want. All right? So let me ask a question, gang. Do I want a standard or an extended access list? I need to be able to block ports. If you recall, standard access lists only allow us to block or permit or deny based on a source address list. But in this, I have to have both source, destination, and I have to have port capabilities. So I'm going to select an extended access list. And next, I have to determine whether I wish to permit or deny. Now, this is where it gets a little tricky because the order in which you place things. Okay, so what we're going to do is we're going to place the most specific item at the top, and that's access to the www server. So what I'm going to do is I'm going to specify, first thing I have to do is specify permit. Now I need to specify what protocol. Now we're going to basically be looking for simply traffic with www, which is port number what? 80. So if I'm going to do that, what protocol do I need to put here? TCP. Next, I need to specify the source, and I need to specify the destination. So what source addresses are we allowing to get to the www server? Any. All systems are allowed to get there, okay? And what is my destination address? 172.16.10.10, and because it's only a single machine, we're going to use the word host. Okay? Let me move this over so we can see this. And then finally, we're going to say equal to, and then www, that's the service that we want. Everybody good? All right, excellent. Now, what's next? What's the next thing we have to filter? Well, actually, we have to finish up access to the www server, and we said that any other service other than www had to be what? Had to be denied. Now, this might be overkill here, but I'm going to put the statement in anyhow, because actually I could do away with this statement, but I'm going to put it in just for kicks. So we say access list 100 deny. Again, I'm going to say, rather than TCP, I'm going to say IP. I'm going to say any host or anything to the host 172.16.10.10. And I don't care about the port number. Any IP traffic. So if I look at just these first two commands, if they're going after the www server and they're using the www port and service, then the first command is true. The first statement is true, and the second statement will not be processed. However, if they attempt to go after 10.10 with any other service, they're going to hit this deny. No. Yes, that's exactly why I was saying it's kind of overkill. Okay? But just to be clear, all right? Did everyone hear what Brian had to say about the implicit deny all at the very bottom? You never see that command, but it's always at the bottom. So if I left this second command out, I really don't need it because the implicit deny all at the very bottom would basically handle that. So access, and in this case, again, we identify the access list, and we want to permit, and we're going to basically permit PC4, which is 10.4, to access the finance server, which is 10.30. So what's the command? The command is IP. What's my host address? .40 to the host 172.16.10.20. Correct? Do I care to specify a port? 10.30. Thank you. I don't have to specify a port because we're allowing for everything. So what's next? We're going from, I believe, PC3 to accounting, correct? Everybody good? All right. So once I define my access list, what do I have to do next? Okay. And rather than using the term port, Jason, let's use the term interface. Okay? Okay? And what direction is this? Out. Very good. So let's take a look at it. You'll notice you have your IP access group 100 out here up on F00. Then we have our access list down below. That looks good. Let's give it a try. So from PC 100, we're going to go to our web server. Would help if I entered in the address correctly. There it is. Web server is up and running. So I'm able to pull up the website. Now let's try pinging it. Anyone want to give me tell me what's going to happen here? Correct. Why, Ken? Exactly. Well, yeah, it would help if I typed the point. I think there's a problem with my keyboard. Okay, destination host is unreachable, which is what we want. All right, let's attempt to go over to PC3, and PC3 is allowed to access the accounting server, which is on 1020. So again, let's see if we can get to it with 172.16.10.20. Request timed out simply because we didn't start up the web service. However, if we go and we ping it, well, maybe not. Yes. Why? All right. Let's take a look at the configuration on this thing. Oh, there we go, right there. Okay, that should take care of it. Oh, thanks, guys. I'm sorry. I'm getting tired. There we go. All right. Okay, there we go. So we now have access to accounting, but let's see if we have access to finance. Destination is unreachable. And finally, let's see if we can ping www, destination unreachable. Looks like our access list is acting as expected. Okay? Now, the second piece of this, we were going to set up NAT. Okay? We've got three types of NAT to use. We've got static, dynamic, and overload or PAT. Which one are we using? Okay, we're using overload. And when we use overload, what we're specifying is that any attempt to go outside, we're going to be using a single IP address. Can you tell me what that IP address is? Correct. That's the IP address that we are going to be using. So back onto our corporate server. And first thing we're going to do is we're going to identify or specify the pool name. And I'm going to simply call it Internet. And then we identify an IP address that we're going to be using. And we give it a starting and an ending, and it's going to be the same because we're only using one. Then what's next? We have to define the Netmask, and I'm just going to say net rather than Netmask. And this is going to be 255.252. Okay? Next, we got to go in and we have to specify how this particular pool is going to be used, whether it's going to be an inside, outside, or pool. And we're not defining a pool of addresses. We are defining the inside. And then we need to specify the source command, and then the list. And we need to specify an access list. Now, in this particular case, what type of access list are we going to use? Standard or extended? Why standard? Is that Jarrett? Okay, Jarrett. Come on, you know. What? What's special about standard? Standard only really looks at one thing. What is it? Yes, it only looks at the source address, and that's exactly what we need. We don't need to worry about the destination address. We're only interested in the source address. Okay? So we need to specify a standard access list, or 10, and then we get into specifying the pool and the pool name. What's the last piece we have to specify here? Overload. Okay. What do I need to do next? Well, really, at this point, what I would generally do is specify the access list. I'm sorry? Well, we have to... Okay? And then finally, what's the last thing I need to do? I have to specify for each one of my interfaces whether it's inside or out. Okay? Now, having done that, let's go back, show our running. There's the definition of our access, our NAT pool. Okay, here's the access list for the NAT pool. Up above, we have IPNAT inside and IPNAT outside. Okay, so now let's do a test. Nope, wrong machine. Pick PC1. And we'll ping the outside server, the ISP server. Okay, so that's pinging. Now let's go up to our router and let's do a show IP NAT and tran for translation. Great, I'm not translating. Oh, take a look. Take a look at our 10 access list. I think it's more than just the wrong subnet. Oh, that's right. Yes, you are correct. Right, right. Yep. It is a wild card. That's what I'm supposed to have. All right, Control A, bring me to the beginning of the line, say no. Control A. Let's see, where... Much better, much better. Okay. I think we're good now. Okay. Running it again. Let's show my IP translations. There we go. Okay, gang. Now, inside local, that's my private IP address. Inside global is my public address. Okay? So what you're seeing is the pings are going out. The private IP addresses are being converted into the public IP address. Now, if I start pinging from, let's say, PC2, let's try 3 as well. Bobby, you're awfully quiet over there. You okay? You understand where I'm going? All right. Okay, I'm not quite sure why. Oh.
That was good.
Yeah, that would. There we go. Now let's go back to our corporate router. Let's take a look at our translation table. Notice it's growing considerable. We've got 30 now, 40 in there. So again, they're all sharing the same public IP address on the outside. When we look at where we're going, outside local, outside global, from the perspective of our router, our corporate router, those addresses are going to be the same because the system isn't necessarily going to know about what's called the outside local address. It just can't see past that. It only sees that public address. Okay? Questions? All right, now here's the big question. Are you going to be able to repeat this? Okay. Well, so what you're saying, George, is you understand it, but not from memory.
You did go through it a little fast.
Yeah, I'm sorry. I'm really sorry, gang. I'm really sorry.
That's why I was trying to help her while you.
Okay. Okay. I have another video that I'm putting together that looks specifically at NAT. And what I do is I break it down into doing static NAT and overload NAT. Here's a question for you, okay? I think I showed this to you on, didn't I show you on Monday? I broke it down and showed you two, Company A and Company B. Didn't I show you that? Okay. All right. And I put the recording up there where I explained the difference between Company A had many systems that wanted to get out, and then Company B had servers that we had to provide a way in. And so we used static routing. Now, those videos are up there now. I don't think anybody's looked at them yet. Okay? I don't know what the hell you're doing with all your free time. So
I didn't know there was a bonus.
it's okay, Ken. All right. But no, take a look at those videos. I think that'll pretty well explain it. But I'm working on another one that just makes the network even easier, okay, to just break it down. Okay? Again, I apologize for going through this so fast, but yeah. Yeah.
You're going to add your stuff, right?
Add what up?
You're going to add, did you record?
Yes, I recorded this.
And that's going to be added up
I'm going to put it up on the site. Okay, just don't expect it there tomorrow morning.
You mean I'm gonna do it at 2:30 in the
No.
morning?
Yeah, I'm going to have to. If I'm going to be driving, I'm going to have to sleep.
If you download the canvas, you can always
All of my links, okay, all of my links are coming off of YouTube.
Oh, okay.
So you can ultimately download it.
Yeah.
Okay?
I don't know. I haven't used the canvas video.
All it does is it goes out to YouTube. So, all right. We did not get to the wildcards. I think, again, what I'll do is I'll just do a video on solving the wildcards. You can take a look at it and see if you have any questions, and then let me know. Okay? Read Chapter 1 in the CCNA security book. Okay? Gang, have a good weekend. It's a little college in Cleveland called Notre Dame. Not the big one. Not the big one, just this a little one.
My work with this time when the Notre Dame players come into Penn State, they throw old donuts, old biscuits, and whatever else they can find at the people's RVs that are coming in.
Really?
Yeah.
Nice. Todd, you good?
Yeah, I'm good. Have a safe trip. Thanks.
All right. Appreciate it, Todd. Have a good weekend.
All right. Bye.
Take care. Bye.
Yeah.
You too.
But the only time we ran into when we had to fix it was when we did the IP, the map separate, or backwards.
Yes.
So we did 255, 255, 255.